This is the 7th example, and we will continue with the 8th example. In this case, we use the bar plot for categorical data, but in a simple way, because we need to learn about these things also in here. Okay, so this is added and import pandas as PD. Okay, and so sample data can be used in here, mp random seed 0 value, and data, the PD data frame can also be created with the with the dictionary values. Okay, just like that. For example, category can be assigned with the list values of the A, B, C, and D. Okay, also values can be given by mp random dot rand function with the for value. Okay, and after that we can assign the SNS set value for the basic figure properties in here. Style, dark grid can be given in here. PLT figure, peak size 8, 6, SNS bar plot. X can be assigned in here as the category. Okay, and Y is assigned values because we have the dictionary values, and data can be assigned with these terms. Okay, PLT title, bar plot for categorical data. Okay, and PLT show can be given in here. And so if I run this code, and then we will have this data A, for example, 0.5, 0.7, 0.6, and 0.553. Okay, and so we can assign the whole category and data by using the PD data frame as a category and the values of these terms. And so also we can assign the X and Y values in a separate way. Okay, this is a simple application, but it's highly efficient for your engineering or mechatronic engineering applications. Okay, in the 9th examples we should talk about the phased grid for multiple plots. Okay, in some cases you will need this data representation in here, like this one. For example, we can generate the synthetic data in here, mp random seed values 0, and data can be assigned to PD data frame in here, like this one. The values of these terms can be assigned to the mp random dot rand 100 values, and category can be assigned with the mp repeat for the A, B, C, and D, but each of them must be assigned with 25. Okay, and so we have the equal number of the A, B, C, and D data in here. And also we can assign to the subcategory in here, mp random choice X and Y with the 100 values. Okay, we can choose this data as X or Y in here. Okay, and so we have the two category, or in one main category, but we have the two subcategory in here. Okay, and so how can we utilize the phased grid in here? SNS. Okay, G is equals to the SNS phased grid values data, and call values is assigned to the what category, and row values is assigned to what subcategory, and margin titles is true. Okay, we need to show the what the margins, and g dot map is a specific function to what the plt histogram and value, and color must be assigned with what the steel blue. Okay, and plt show must be calling in here, and so if I run this code, and then we will have the what the category A, category B, category C, and category D values, but we have also two y and x values. Okay, and so this subcategory represents what the y with the what with these values A, B, C, and D are given in the what this subcategory y values, and in the another terms we have the x values in here, like this one. This is the subcategory, but this subcategory contains the what the main category values A, B, C, and D, and so you can easily build the what the model or the representation for your data set in what in a subset or the set of your data representation. If you are using only figure plots in here, and then you will have only 4 category, but by using this phased grid we can assign what the y possess the A, B, C, D, and x possess the A, B, C, D. Okay, and so we can create the main subcategory and the subcategory by using these terms or this function, this representation. Okay. And also we need to talk about the swarm plot for distribution of categories. Okay, for example, the import seaborn library as SNS, import matplot lib.pyplot as plt, and import numpy as mp. Okay, we need to generate the what the synthetic data, and after that mp random seed can be assigned with the 0 values, and data is assigned to mp random normal value. The size of the what the 103, and location is assigned 0, and scale is equal to the 1. Okay, and categories is assigned with the mp repeat values A, B, and C with the what 100 values. Okay, and so what is swarm plot? Swarm plot SNS set should be assigned with the style value in here, white grid, and plt figure fig size is equal to 86, and SNS swarm plot x must be assigned with the categories, and y data flatten should be given in here, and hue categories, and palette viridies. Okay, and after that also we should give what the legend is false, and plt title swarm plot for distribution of categories. We can find this value, and plt show must be represented. So these swarm values just like the violin plots, but in this plot we just only used what data representations like this one. Okay, and so we can see easily that these terms are represented as it's kind of the scatter plot, but we can analyze this data by using these terms. Okay, So you can only use the what the while input in here, but maybe in your application, I don't know now, but this is more useful representation for your distributions of the categories. Okay. So, any question? I will share the second project in the Sunday for this week, okay? And after that, you will have the 1 week to build your project. But this project is smaller than the previous one, okay? It's just kind of the homework. Abdulhak. Yes, I checked, but this I will explain the whole the notes in the classroom. Okay. So in the second topic, we need to talk about the Scipy Optimization Toolbox. Firstly, we need to give some basic conditions in the what these terms optimization in the parameter estimation. Okay, and so in your mechatronic application, you will have the what the system dynamics model or the dynamic system with respect to time. Okay, and so in each model or in real world application, you need to optimize the system to find the matching parameters, like the mass or spin or damper coefficients for your real system. And so this Scipy or scientific Python library is utilized for for parameter estimation optimizations. Okay, and so in the real world application, you need to build this model. Real world application mandates us to build these kinds of optimization to model the R system representation in the mathematical world. Okay, and so our objective is that some basic function can be used in here, and then we can build the R model. Okay, and so this optimization in the parameter estimation is the important part for the mechatronic application, because if you want to control the system or if you want to control any machine learning parameters, we will find out what is the best values for representing real world application. For example, this may be A or B, but you need to find out. Okay, and so I will create some basic examples for the Rosenbrock function in here. X1. Okay, and so import numpy smp should be given in here. Import matplot lib.pyplot should be given as the plt, and from scipy dot optimize function import minimize. Okay, so what's the Rosenbrock function? Returns the 100 times x1 minus x0 over 2 plus 1 minus x0 over 2. This is the basic stabilization rule to your ML application, machine learning application, on the control system application. Okay, this just kind of the stability index for your system. You don't know anything about the stability or control or system dynamics or the machine learning, but you will find out what the Rosenbrock is implemented for these objects. Okay, and so you need to right now you need to not learn about the underlying mechanism of the Rosenbrock, but we can optimize or minimize the hard system to test the specific conditions. For example, conditions xmp linspace minus 2 to 2 100 data in the y minus 1 and 3, and x and y mp mesh grid can be built with the x and y. Okay, and z is assigned with the Rosenbrock function with in terms of the x and y. Okay, and so in each calculation for the what the x and y values, we fit the what the Rosenberg function to what the x and y value and generate to z values. Okay, and so we have the 2D dimensional data representation in here. Okay, and so after that we need to plot our results. PLT figure, fixed size 6,4. PLT contour is another function or utilization of this term. X, y, and z levels is equals to the MP. Log space is the another space in here, 0.5, 0.3.5, and 20 values, and CMap can be conditioned with the varieties. Okay. PLT X label, X, and Y label, so Y, and X0 MP array can be assigned with the 0 and 0 values, and the results of this what the minimize function. This minimize function returns to the what is the optimal range or optimal point for this Rosenberg function. We don't know yet, but if we have this kind of data and we have the function, and then we can minimize this system, this function, in order to find out what's the minimum values of the x and x1 and x0, or what's the best fitting values of the x and y values. This minimize function returns to these terms. And so Rosenberg function should be given in here, initial condition should be given here, method the BFSGS. This is some kind of method for the optimization algorithm in here, and we also with the callback function in here. Lambda is specific kind of operator. It's given in the Python. We should draw at each line of the PLT in here, x0 and x1, and we should give the arrow, and the marker is set with the marker size is equals to 3. Okay, and so what's the optimized path or the smallest values of this script? Optimization path on Rosenberg function, and this plot directly shows us what's the best fitting values for this algorithm. Okay, and so in this algorithm we have this red dot points in here. Okay, and so this is the smallest values for for our region, or the optimization path should be given in here, or this is the best way to go this algorithm is running. Okay, and so you don't need to learn about the underlying mechanism of the Rosenberg function, or what's the purpose of the motivation of utilization of this function, but this function is always utilized to to check the stability of the real world application or your machine learning applications. Okay, and so this Rosenberg function is minimized by using these codes in order to in order to show the performance of your algorithms. Okay, so in the second example we need to write about the seaborne addition, because in the first lesson we will talk about it, and so this code may be copied just like this one. Okay, but also we need to add the seaborne as SNS in here. Okay, so seaborne style can be added with the SNS set. Style can be assigned with the white grid value. Okay, and path can be assigned with with these terms. Okay, and also we can define the callback function in here like this one, x, and path append x, and we can store the whole data in here like this one, and so x0 value can be assigned MP array, 0 and 0. Okay, and result can be obtained with what the minimize function with the Rosenbrock function x0 method assigned with the what the bfgs, and also callback function assigned to callback in here. Okay, so the plotting values can be created the figure fixed size 8 6. Okay, and contour can be created with what PLT contour x y z levels MP log space in here with what 0.5 3.5 and 35. Okay, and C map can be assigned, for example, magma. It's the different color name. Okay, and PLT C label can be assigned with the what the contour with the inline function as true. Okay, and the font size can be assigned with the what the 8. Okay, so this path can be built with what the MP array path, and so we have the what the appends of the what the R optimization algorithm path. For example, we can start to what the 0.0, and so we go to what the best way or optimum path to the what to R range. Okay, and so PLT plot is assigned to path 0, path 1, and row marker size 3, and label is the optimization path. Okay, so PLT X label X, Y label Y, and PLT title optimization path on Rosenbrock function. Okay, so also we should add the text to the what the mathematical index. Okay, 0.5 and 2.5 and F minimum at result x0 to F. Okay, and also we should give the what the result, just like copy of these terms 1. We have the x and y optimal values in here. Okay, and we should give the what the new line, and also F function value result fun dot to e. Okay, and new line, and F iteration number also given in the what result dot net. Okay, so should give the what the font size equals to 9, and B box equals to what the dictionary values face color is equals to white, and the alpha is equals to 0.8. Okay, so after that PLT legend should be given in here, and PLT show must be given in here. Okay, so if I run this code, we will have the Rosenbrock function optimization path, or the energy function of this path. But in this function we have some additional data. Optimization path is represented into the what this line, but in this case, in the seaborne case, we will have the what the each line energy representation. Okay, but in these terms we have the, for example, 1000 energy form, 800, 600, these highest values. But in this case we have the 0, the 8, 5, 7, and this the smallest values on these terms, and so this is created for the what for this line is the optimization path on these terms, and so minimum at is equals in the what the 1.1, right? And so we have also 19 iteration for the what the minimization problems. Okay, this is how we can use the Seaborn library in order to generate the our path notions in here. Okay, and so in your energy application, in your control application or the machine learning application, they are important parameters to visualize your results by using the optimization problems. Okay. So, any question? If there's no question, that's all for today, because in Friday we will continue with the filter operation in Python programming language, because in the next sessions of next years for your lessons, for example signal processing or the control system theory or the system dynamics, you will utilize the filtering applications in order to remove the noises or the uncertainty or the disturbance data from your data set. Okay, so in Friday we will talk about it.